All right, so now we're going to practice, it's still order of operations, but first we're going to practice substitution involving exponents. So I'm going to take the x's out. I'm going to put 5s in. Remember, anytime we substitute, we use parentheses. So what is 5 to the second power? 25 minus 8 times, what is 5 to the third power? 125. Good. What would I do next? Yeah, multiply by the 8. So what is the 25, you leave it alone. What is 8 times 125? 1,000. Good. And then you have to do 25 minus 1,000. Very good. Raise your hand if you have any questions. All right. Anyone need more time with this one? Lot going on here. All right. Check this guy out. Woo! We have 3. And then take the a out, put a -6 in. Square it. Take the b out, put a -2 in to the third power. Minus, open some parentheses. You have your -8, then your minus, then your -2 for the b. Close it up again because you open 2 sets of parentheses, and then the 4. So it looks like I did a lot there, but remember, all I'm doing is taking the a's out, putting -6's in parentheses, taking the b's out, putting -2's in parentheses. Now, we haven't had to do anything as far as parentheses because all the parentheses so far have been simplified. Here, it's not simplified yet. So before you do anything with the exponents, you have to simplify what's in those parentheses. So I still have the 3, the -6, squared, the -2 to the third, the minus, and then in those parentheses, what will I have? What is -8 minus -2? What is it? What is it?
6.
What is it?
-6.
-6. -6 is not the same thing as 6, so be careful on that one. Alright, next. Now we can do exponents. Now, when you have a negative number taken to an exponent, you can either do the signs in your head, figure out if it's going to be positive or negative, or you can use the calculator. The calculator knows how to handle negatives if you type it in right. So for example here, you have to type it in exactly how it looks. Open parentheses, it's right above the 8. Negative, the negative right below the 3. Then the number 6, close the parentheses, then to the second power. If you don't use the parentheses, it will keep the negative. It won't actually square the negative, okay? So put it in parentheses. If you're getting -36, you're not handling your negatives properly, okay? You should get a positive 36 here.
Yes.
So double check that. Did you get a positive?
Yes.
Okay, good. Same thing on the next one. So open the parentheses, -2, close the parentheses, then to the third power. See what it gives you. -8, perfect. In the back, we have a minus. Do the same thing. Open the parentheses, -6. Close the parentheses to the fourth power.
1,296.
Any questions so far? All right, up front, you need to do 3 times 36 times -8. Uh-huh.
36.
Uh-huh.
And make equals -8, -8.
64?
Yeah.
Good. And then you still have the minus 1296?
It's -208, 2060.
Very good. Everyone else that's not really answering, are you practicing typing this into the calculator?
No, we did this last year. I'm gonna tell you one time.
You cannot just listen to someone else do it and then go do it independently. You have to practice how to type these things in. It definitely matters. You did this earlier in this class as well. This is a review of exponents. Yep. All right, any questions? All right, we have one more on this side of the notes. Again, the calculator is going to really come into play here, so make sure you have it handy. Anytime you have a fraction like this and you're doing the order of operations, it's sort of like a grouping symbol on top and a grouping symbol on the bottom. It doesn't matter which one you do first, just simplify the whole top and then simplify the whole bottom, or the whole bottom and then the whole top. It doesn't really matter. What is 8 plus 2? 10. What is 4 to the third power? Okay, now you cannot divide 10 by 64, so what we want to do is reduce this fraction. You can do it in your head, or you can use that wonderful tool right in front of you with the ABC button. So you'd hit 10 ABC 64 equals, and what do you get? 5 over 32. Good. I would not be simplifying by hand. Use a calculator. They will always be available to you. What are your questions? All right, jump to the back side of your notes. Here's some more definitions for you. So the first one is exponential notation. It's an expression that's written with exponents. So if I say write something in exponential notation, it means write it using exponents. And then this next word, it's monomial. We'll talk a lot more about these tomorrow, but for right now, a monomial is an expression with just one term. Terms are separated by plus signs and minus signs, so if you only have one term, there's no addition or subtraction. Everything's held together using multiplication, so that's a monomial. All right, now I want to write this monomial, so there should be no plus or minus signs, using exponential notation. So I want to rewrite this using exponents. Okay, you could put a 1 in the front if you want. I'm not going to put the 1, it's not necessary. But this is like x to the what power? Yep. You have 5 x's being multiplied together. So it's like x to the 5th power.
Oh, that's it?
That is it.
Oh, okay.
We're just rewriting it using exponents.
I did it.
All right. Here's number 6. So go through piece by piece. What's 3 times 2?
Okay. Okay. 6.
6. What's A times A times A times A?
7.
What?
Huh? 4.
A to the 4th. Good. You can't put like A, B, C to the 7th because that means that A, B, and C would all be happening 7 times. Okay? That's not true. You got to just put the ones that match.
1.
So all the A's. You could put B to the 1st, but that's sort of like putting a 1 in front of an expression. It's not necessary. If you don't see an exponent, you can assume there's a 1 there. So I'm actually not going to write B to the 1st. I'm just going to write B.
Okay.
And then C to the 2nd power. Very good. Raise your hand if you have any questions on this one. All right, number 7. What do I have?
X to the 2nd power.
X to the 2nd power.
Y to the 2nd power.
Y to the 2nd power.
Just Z.
And then just Z. If you put Z to the 1st power, you would not be wrong. If you put a 1 in the front, you would not be wrong. They're both just not necessary, so I'm not going to waste my ink on it.
Mississippi.
What are your questions on number 7?
Mississippi.
Number 7 is not Mississippi. Do you have any questions on number 7? Okay, now we can talk about Mississippi. So, anytime you have a big hodgepodge like this, do it in alphabetical order. It just helps us all have our answers in the same form. So let's start with the I's. How many I's?
3, 4.
Okay, so I would start with I to the 4th. Then what?
S's.
Just M. We're going in alphabetical order.
Okay.
Okay, then what? The P's. So P to the 2nd power, and then all those S's to the 4th. Very good. You just wrote Mississippi using exponents. That's fun. Questions? Alright, here's just some extra practice, so I do want you to have these in your notes, but it's a little harder than the other ones, so that's why I call them extras. What is negative 5 times 3? And then C to the 4th. Very good. So do I have 4 15s? No. Remember, the exponent's just the number that it's right above, the base. The base is the only thing that's repeating. If you wanted to show that you had 4 negative 15s, you could put it all in parentheses, but we're not doing that. That's wrong. Okay? Other questions? I did negative 5 times 3, and I got negative 15. All right, here's the next one. What's 2 times 3 times 5? 30. Now the A's are separated, so be careful. We have A and A, so that's A to the 2nd. Very good. There's just one lonely B, so B to the 1st, C to the 2nd, and then what? D to the 3rd. Very good. What are your questions? Alright, now we're going to practice that in reverse. So we call this the prime factorization. Okay? So expand into the prime factorization. So how would I write C squared?
C times C.
C times C. Very good. Alright, how would I write 7 x to the 3rd y to the 5th?
You can just put X.
7 and then XXX, yes. Y, Y. Now, very good point. She said, I forgot the multiplication sign. Remember, if you have a number next to a variable, that already means multiply. Or a letter next to a letter, variable next to variable, also means multiply. So if you want, you can go through and put all these dots. Or you could use parentheses. Don't use little x's, because then we won't be able to tell which one's an x and which one's a multiplication symbol. So if you want to put something in there, use the dot or parentheses. Or you could just leave all those out. Questions? Alright, we're going to kick it up a notch because you can write 12 using factors as well. This is where we do what's called a factor tree. And we won't do a lot of these, so don't freak out. But we will do a couple today. What's a way to break up a 12? 2 times 6. 2 is prime, good. What's a way to break up a 6? 3 and 2. So these numbers are prime numbers. They can't be broken up any further. Just like an A times an A times an A. We're just expanding it out in the simplest way possible. So 12 written out in its expanded prime factorization is 2 times 2 times 3. Whoops. There we go. Now we can worry about the variables. So I have 1A and 3 B's. Now in here you do need those multiplication symbols or else it would look like 223. So don't do that. But the letters, between those variables, you don't particularly need them. Alright, so the factor tree was new on this one. What are your questions about the factor tree? I broke up 12 into its prime factorizations. So like what two numbers would multiply to give you 12? And then break each of those up into two more numbers that would multiply to give you that number. We're going to do a few more of them together. Alright, jump to number extra, the last one. So again, I can break up the 8. So off to the side, let's do some factors for 8. Anyone have any? 2 times 4. Can you break up a 2 any further? No. Can you break up a 4 any further? Yes. To another 2 and a 2. So the prime factorization here is 2 times 2 times 2. Then what do I need? M, 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 M. Then what? N, and then P, P. Any questions? Alright, there's a couple like that on your homework. I'm going to give them to you now. We're going to do the trees together, just because I know you might be a little rusty on your factor trees. So on your homework, it says 6.1 homework. Let's do the last two together. Let's start with some trees. How do I do a tree for 24? We could do 2 and 12. Good. 2's prime, so you're done on that branch. What about the 12? 2 times 6. The 2 is prime again. Done on that branch. 2 times 3. Prime, prime. So I would write this out as 2 times 2 times 2 times 3. Then what? A, 1B, 2 C's. Very good. Now, if you're not sure if your tree was right, go back and check it. What is 2 times 2? Times another 2. Times a 3? 24. Ding, ding, ding. You ended up right where you started. That's what you hope happens. If not, you need to go back and redo some stuff. Alright, last one we're going to do together is number 16. So let's do a factor tree down here for 16. 2 and 8 works. 2 and 4. 2 and 2. So 2, 2, 2, 2. Then I have an M. Oh, I'm going to run out of space. I'll do what students do. It annoys me, but I'm going to do it anyway. N, 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 P, and P. Again, you can go back and double check. 2 times 2 is 4, times 2 is 8, times 2 is 16. You have 1 M, you have 4 N's, you have 2 P's. The rest of this worksheet you should be able to handle on your own. You have the rest of class to work on it. If you finished it, put it in the bin. If not, take it with you and finish it tonight for homework.